Welcome everyone, you're watching Simulacra and I'm Bryson. This is session 8 of how I'm building a decentralized application. Now, in today's session, we're kind of doing a lot. We are going over how oracles work. We're setting up the Chainlink price feeds in the application. We're going to build out the price converter and some of the other code and source code for the community to pull funding, deploying, and withdrawing, as well as some of the other helper config code files that will aid in our application being able to deploy smart contracts to the blockchain. We're also going to go over getting test tokens and setting up a demo wallet in MetaMask. And then we're going to live test posting a crypto address and retrieving the balance for that address in the application. And remember, if you have any questions regarding anything that we go over in this video, remember to post that question in the comment section below. This will be a great session and I'm ready. So let's get into it. So today's session is all about testing. We need to test and make sure that our backend actually works, that users can actually deploy a community pool, and users can post an address and receive a balance. So first, we're going to test if users can post an address or a transaction hash and receive a balance from that address to their balance list. And so to do that, we're going to need to get pricing data, price feed data from an oracle. And an oracle is just an entity in the decentralized finance world that allows on-chain data to interact with off-chain data. So the oracle that we're going to be using is called Chainlink. Chainlink is a very useful and secure oracle. So this is how it works. Chainlink nodes get data from external data providers or exchanges. That data is then brought through a network of decentralized nodes, and then the Chainlink decentralized nodes uses a medium to figure out the actual price of the asset and then delivers the information to a smart contract. And this smart contract is called a reference contract or a data contract or a price feed contract. And that contract, that smart contract, is on chain. And so this allows other smart contracts to use the data from the reference contract and price information to power the decentralized application. To get actual price data from Chainlink, we can just go to chainlink.com. This is the dev hub for Chainlink. We're just going to go to resources, and then we're going to go to docs. And here is all of the information regarding the Chainlink data feeds. So they have overview, get started, feed addresses, price feeds is where you'll go, and you can come down, and as you can see, we have mainnet and testnet, and then we can go between the different networks to get different addresses. And the address info will just be what the pair is. So if we go next, and then we go next, let's see if we can find Ether to USD. We'll just use Bitcoin to USD. And so if we wanted to get price information of Bitcoin related to USD, we would take this address and use it in the smart contract that we're developing on our application, or we would give this address to our agent to build out the file for retrieving balances from an address. And so this is not the address we're receiving balances from, but this is the address that will help us retrieve the balance in terms of USD, and we're getting that pricing information from our Oracle network, which is Chainlink. So back in Cursor, I already created a folder for where all of the tests are going to go. So I'll open this and I'll create a new folder inside, and we'll call it price feeds. And then inside of price feeds, we'll create a file, and that file is going to be called v3 aggregator. And V3 aggregator is just a price feed aggregator that was from the Chainlink documents website. And we'll say it's a .sol because it is a, and we'll name it a .sol because it's a Solidity contract. So cool. So that opens up the V3 aggregator file. And so that opens up the v3 aggregator.sol file. And I have already written up a smart contract for this process before. And so I'm just going to use my smart contract from another project and then paste into Cursor. And so I've already created this file for our v3 aggregator.sol. I used the template file from Chainlink and then made modifications for another project when I was trying to get the price feeds for Ethereum and Bitcoin. So I'm just going to paste that into Cursor. And as you can see, we are writing in Solidity, and the file is importing the aggregator v3 interface from the pathway at Chainlink. And if you go to this pathway at Chainlink, it will take you to their GitHub where you can view their example v3 aggregator file. And so now that we have this v3 aggregator.sol file, now we can import and get price feeds from Chainlink. And so we'll need to also create a price converter.sol smart contract in Cursor so that our application can actually take the prices from. And so now that we have the v3 aggregator.sol in Cursor, we also need to create a price converter file so that our price can be converted correctly. As it is right now, when you retrieve a price feed from Chainlink, and so when we get the price feeds from Chainlink for the assets, whether that be Ethereum or Bitcoin, we still needed to convert that price to the amount in USD. And to convert that price to the amount in USD, it would be the asset price times the amount of the asset I have. And for Ethereum, it would be divided by 18 digits. And so I'm going to create another folder called source for our source code. And then inside source, I'm going to create a file called price converter. In priceconverter.sol, I'm going to copy and paste the code that will convert our asset price into a price that is actually in USD so that our users can use it. So in this code, again, we're importing that aggregator v3 interface, and we already have that v3 aggregator.sol file in our test folder. And so we're opening up a library called price converter. We're writing a function that goes and gets the price from this v3 interface from Chainlink. And then the get conversion rate function takes the Ether amount and the price feed from the aggregator v3 interface and returns the amount in USD by taking the Ether price times the Ethereum amount divided by 18 digits. And so that will be the actual Ether to USD conversion rate after adjusting for the extra zeros. And then we're going to return the amount of the Ether in USD. Okay, great. So now that we have our price feeds that are aggregated from Chainlink, and we have a way to convert those prices to an amount in USD that is usable for our users, now we need to check if the agent can actually use the two files that we just created, and we can post an address in the application and retrieve a balance now that we have all of our information from Alchemy and Chainlink. Alchemy being our node and RPC infrastructure, and Chainlink providing pricing data. So now that we have the v3 aggregator and price converter.sol squared away, now we can actually prompt the agent to make sure that it can retrieve prices from Chainlink. And then we're going to make sure and test that we can post an address in the application and retrieve a balance. And this should all work because we have our price feeds from Chainlink and we have our node in RPC. If you remember from last video, remote procedure calls allows one program to request a service from another program on a different network without needing to actually understand those network details. And so we have our Alchemy API and we have price feeds from Chainlink. So we should be able to post an address and retrieve the balance. So let's prompt our agent and see if it works. And so I gave the agent a very simple prompt. We're testing if users can post an address, transaction hash, etc., and receive the balance. I'm telling it has access to the Alchemy API keys for remote procedure calls and node infrastructure, and then it also has access to the price converter and the aggregator that I just created. So I want the agent to check if these files work and if the agent can actually price feeds from Chainlink and I want to check if the agent can actually receive price feeds from Chainlink. So let's put this in plan mode and see what kind of plan the agent comes up with. And so this is a really, really good case of where putting the agent and cursor in plan mode and reading through the plan first before you let the agent build is always very, very good to do. So we have two caveats. We have three caveats. It says the scaling is hard-coded to 1 to the 10th. Production code often uses 10 to the 18th minus the uint 256 of the price feed dot decimals. So we have three caveats that the agent said that both the price converter and the v3 aggregator files are good to go. But the scaling is hard-coded to 1 to the 10th. And production code often uses 10 to the 18th and then all of this minus uint 256 of the price feed at the index of the decimals and so on. Also, there's no check that our answers are greater than 0 before casting to that uint 256 value. Also, we don't have a staleness check, so we don't know how stale our information will be at any given point. These prices that we're retrieving could be hours old, and that wouldn't be useful for our users. And so the main things that I really want the agent to do is add the Foundry project under community pool and then start using Foundry to test that we can actually deploy that v3 aggregator.sol. And so I'm going to let the agent do all of these things, and then I'm going to come back and go to the dashboard and see if we can actually get a balance from a crypto address. And so our agent recommends a few things before we start building. It recommends that we use Foundry. And basically Foundry is simply just the industry standard framework for Ethereum application development. You can build, deploy, and test your smart contracts using Foundry. And Foundry can simply be imported through the terminal. You may have to go to Homebrew to install Foundry, but once you have Foundry installed, you can just go into your terminal and say Foundry up, and a Foundry and testing environment will appear. So I'm going to let the agent add Foundry and then do some Foundry testing because I want to really make sure that our smart contracts work and that our application can use real price feeds from external data sources. But the problem with that is that we want those data sources to be decentralized. And so they need to go through a decentralized oracle such as Chainlink. All right, so now that I've explained what an oracle is, I think we're ready to officially test the balance retrieval service for this app. So we're going to go to the landing page, sign in, and then get a crypto address, post it in the application, and then see if we can actually get the balance of that crypto address. And to do that, I'm going to use a demo MetaMask wallet that I have. We're going to go through putting some Sepolia tokens in it. We're going to explain what Sepolia is, and then I'm going to take the address from that demo account, that demo wallet, and post it in the application to see if we can retrieve the balance. So let's go. So to test this application, we need to go get some Sepolia, some test tokens. And Sepolia is just a test network for Ethereum that was launched not too long ago. And it operates independently of the main Ethereum network, but it closely simulates its conditions. So basically, it allows developers to see how their code will behave in a live environment. And the testnet also has its own block explorers and allows users to view those on-chain data specific to Sepolia tokens. So once we go get the Sepolia from the faucet, we can actually go to the Sepolia block explorer and see that transaction being sent to our wallet. And so remember, Sepolia uses test ether, which serves the same purpose as ether on the mainnet, but it doesn't have actual value. So it's only for deploying, testing, building decentralized applications. And so we get fake tokens to deploy to our application to see what happens in a development or production environment. And before, I was trying to develop a application previously, a decentralized application previously. To test it, I sent $10 worth of Bitcoin to my application. And as you can probably guess, that Bitcoin is gone forever. And so that is the power of using test tokens like Sepolia to test your application. So let's go get some Sepolia now. All right, so to get some Sepolia, you can just literally type in on Google Sepolia faucet. And so there's a lot of companies that provide Sepolia tokens. Alchemy provides a faucet. A couple of other these companies provides a faucet. But I always have seen that Google Cloud has worked the best when I am wanting Sepolia, when I am in need of some Sepolia when I'm developing. So we go to Sepolia Ether and we paste our wallet address or ENS name. So that allows me, I need to go to MetaMask and I'll type in my password. And so this is what the MetaMask wallet looks like. As you can see, I already have a little bit of Sepolia in my account. If I go up here, I also have some Sepolia in another account, on account 2. And so I will today not actually go and retrieve Sepolia from this faucet. When you are using Sepolia and going to use the faucets, regardless of whatever faucet you use, make sure to seldomly use your Sepolia and just be responsible with your usage in general, because the devs are still putting their time and energy into upholding the infrastructure so that you can use free tokens, because they don't make money when you use free tokens. And so, yeah, remember to be responsible with your Sepolia usage. But if you didn't have any Sepolia and you wanted some, you would go inside of your MetaMask account, go to the account that you want to send the Sepolia to, and then you would come here, and these are all of the crypto addresses, the public addresses for each of the networks. And so since I want Ether Sepolium, I'm going to choose the Ethereum network. And so actually down here, before I do that, make sure that you are on the same network as the token you are receiving or trying to send, so that those tokens just don't get lost in cyberspace, essentially. So cool, we're on the Sepolia network. So we're going to take our Ethereum public address, have it copied. We're going to come over here, and then you would press get 0.05 Sepolia Ether. And once that happens, you would get those Sepolia in your MetaMask wallet, and that would show up here. And so to actually see that transaction on the blockchain, remember, there's still going to be a ledger of this transaction, even though that the Sepolia was free. and it doesn't have a value to it, you can still see it on the Etherscan blockchain, except for Sepolia. So you can just go to Google and type in Sepolia Etherscan, and this would be the testnet Sepolia Etherscan blockchain. And then you would paste in your address, the same address that you used to get the Etherscan that you posted into the faucet. And then Etherscan will list all of the transactions and the transaction hashes for that address. So 111 days ago, I got some Ether from a faucet, and then the rest of these outs are me playing around with contracts and funding contracts and basically practicing to build this decentralized app that I am building now. Okay, cool. Now that we know we have Sepolia Ether in the wallet, we can come to our landing page. We're going to sign up, we're going to create an account, and we're going to post the crypto address of that wallet, of our MetaMask wallet, post it into the application and see if we can retrieve the balance. I think the balance was 0.241 Ether. And so we should see 0.241 Ether in the application. So we created an account. We're on the address balance retrieval dashboard. I'm actually going to come back to my agent over here and tell it that I'm about to post a crypto address in the address balance retrieval dashboard and to stand by so we can see if the balance will actually be retrieved when I post this address. And so again, I'm going to go get my public address from my MetaMask wallet for the account that I want to get the balance of. All right, so I'm in my MetaMask wallet. I'm going to copy the address for Ethereum because I want to retrieve the balance of my Sepolia Ethereum from this wallet. And then with that public address from my MetaMask wallet, I'm going to come back to my application and post that address and press add address. So it's saving. Let's see what happens. Okay, so our application gave me back, it outputted a few things. So the address slash hash, I'm going to assume that is the same address that I put in, even though it is condensed. It also gave us back the actual type of network or token that was associated with that address. So that's very good. It was a Sepolia Ether address, so that's good that our application recognized that. And then next is the actual balance and amount of the wallet. That is the big thing we want to see. So it says 0.4185 for Ether, and we have that right here, 0.42 Sepolia Ether. Perfect. And then it also says +1 TOC and 15 transactions. I'm assuming +1 TOC is a token. And I know I have ZK Sepolia testnet in this account. And so I have a little bit of Sepolia testnet. And so I think since the ZK Sepolia testnet is not a part of the actual Ether, is not a part of the actual Ether network, I'm assuming the application didn't return for that reason. So I'm going to see if it will return the balance if I post the crypto address for the ZK Sepolia testnet also. Okay, so its account. Okay, so it seems like my application is counting this Ethereum address as just one address for this entire account because the ZK Sync Sepolia testnet, even though it is a ZK Sync Sepolia, Sepolia is using the Ethereum network. And so I think that's what that means. One token +1 token means I have ZK Sync Sepolia testnet, and it's accounting for that. And then 15 transactions. So if we post this address into the Etherscan Sepolia testnet Explorer again, we can see 14 transactions. And then if I go to token transfers, we have 1 token transfer. And it seems like this is 127 days ago. So if we go back to transactions, we have 1 token transfer, but I don't think that is that because that is us getting, because that's us getting Sepolia from a faucet, and this token transfer looks to be a Chainlink token. And so I think that's where our 15 transactions are coming from. I'm going to do some more playing around and tooling to make sure that our application is actually retrieving relevant and accurate information. And then in terms of the balance, well, we know that Sepolia doesn't have a actual value. As you can see, it says 0 right here. So it makes sense that our application would not return the balance in USD of this crypto address. And so I definitely need to do some playing around to make sure that the information is accurate, but I think this is a good indication that the address balance retrieval service is working. And so I'm going to continue to work on that. I'm going to test. I think this is a good indication that the address balance retrieval service works correctly. So let's use another crypto address from this same MetaMask wallet, but a different account, and let's see what happens. So in this account, we have 0.25 Sepolia in here. So we'll take this Ethereum address, copy, and let's post into our application and see what happens. So it's saving. It's saying that this account has 0.025 Sepolia Ether. That is correct. And then one transaction. So if we go back to the Ether scan for Sepolia and we type in that transaction, we can see one total transaction. And so it looks like the application is correctly taking the crypto address or transaction hash, returning the type of network or token that is inside of the wallet, and then returning the amount of token that is actually inside the wallet. And since these Sepolia tokens don't have any value in USD, the application is not calculating the balance in USD. Now, what is to be determined is what will happen with a wallet that has multiple different types of tokens and addresses. I want to make sure that the application will list out all of the different types of tokens that are in the address and their amounts. I don't want it to just list the first one and then plus one token. I'm going to assume our application did that because this plus one token referred to a ZK Sync Sepolia testnet token. And so I want to see if we have Ethereum and Sepolia Ethereum and Bitcoin in a wallet. Will our application be able to differentiate between all of those? And so that's probably going to be a way longer video. I think I'm going to end this session here and begin the next session, session 9, with fully building out how the application will deploy community pools that other people can fund with different tokens, and the owners of those community pools can withdraw the funds from. So I hope you all enjoyed session 8 of building a decentralized application. I am going to get into the next session now and record now because I am pretty hyped that this application is coming along so well. So if you have any questions regarding what we went over in today's video, remember to drop that down in the question section below. Remember to like, subscribe, support the channel, send to your friends and family, and you are watching session 8. This is another video from Simulacra. I'm Bryson, and I'm out. Bye.